Alright guys, this is the first time I've ever used this recorder on my phone, so bear with me here. What you're looking at is my Renogy control panel. It's all Wi-Fi, so you're looking at live data from my Renogy system, which consists of my four 48 volt Renogy batteries and my two Renogy inverters. Well, one inverter and one inverter, or one charge controller, excuse me. So this Renogy one is what I use for communication via Wi-Fi, so that if I'm away from the unit, my RV, I can see everything that's going on. I'll also get alerts for it, for any low voltages or high voltages or anything else, disconnects, whatever. My battery voltage, you can see by clicking the batteries, we're at 98.87 with 200 amp hours of capacity. That's four 50 amp hour 48 volt batteries. People always wonder, they don't understand how amp hours work with voltages, but the higher you are in voltage, the lower your amp hours are going to be for a comparable battery. So if you have a 50 amp hour 48 volt battery, that is going to be equal to a 200 amp hour 12 volt battery. You're going to have the same amount of power in each one. So they don't make too many 200 amp hour 12 volt batteries that are lithium ion, that don't take up a footprint bigger than a regular battery. So the benefits to going to 48 volt are much better if you're going to run any kind of high draw unit, anything like a AC compressor or your mini split. You're going to want a 48 volt system. The 48 volts, when you invert it to 120 volts, you lose a lot less. You're also able to use much smaller diameter wire. When you run a 48 volt system, you're going to pull higher voltages but less amps out of that 48 volt battery to do the exact same thing that you would do with a 12 volt system. Now, if I go through here, you can see I have 4 batteries, so whatever. We're not pulling anything basically from my batteries. This mini split right now is running. Let's go over to the inverter. That shows all the information. The inverter has already dropped down to 1428 volts or watts. I'm sorry, that's what it's putting out total right now. Like I said before, we have about 400 watts of parasitic draw. So the inverter was putting out about 1800 watts when I first turned the air conditioning on. That was about 10 minutes ago, and I'm still asking for 67 degrees, and it is down to 81 degrees inside the camper. So we've dropped 3 degrees since I turned it on about 10 minutes ago, and that was with an outdoor temperature around the same, well, 82, 83 degrees, and almost 100% humidity over here today. So going through this, you can see the inverter from the mini split is lowering itself automatically as the temperature inside the RV drops. It automatically ramps down the compressor on the mini split so that you're drawing less power. It's the best thing that you can do is get rid of your roof units and install a mini split. You'll save so much. Even if you're just hooked up to shore power and you're paying for your electric bill is going to get cut in half. Let's see, I don't think there's anything else in here that you really need to look at, but you can see that we are not hooked up to shore power up here. We have nothing hooked up. We're running completely from solar through the battery, through my charge controller, and you can see where my input's coming through. Now if you look right now, we are generating 818 watts off of my main solar array. So 818 watts is coming through, and I wish I could show you this right now outside, but it was in my previous video. We are completely overcast with no sunshine whatsoever. It's cloudy and overcast. My main set of panels is putting out over 800 watts. And if you look at my other charge controller, let's see, this little guy is putting out just over 200 watts. So we are putting out, just in solar alone, on an overcast day, just over 1,000 watts. We're putting out 1,000 into solar, and we are drawing 1,400, give or take. So even at max draw with my mini split running on an overcast day, my pull from my batteries, that's going to ramp down from 1,400. That pull is going to ramp down to right around 700-800 because well, actually more than that. Your mini split is going to pull around, this one in particular is going to pull around 600 watts by itself. Once the temperature comes down, in order to maintain that 67 to 69 degrees, this mini split pulls 600 watts, 650 sometimes. So add that to the 400 watts of residual stuff like our fridge, freezer, everything else, all the other parasitic draw, we've got about just over 1,000 watts of normal draw. Well, my AC on an overcast day, or my solar on an overcast day, just proven to you, is putting out just over 1,000 watts. So I have no draw whatsoever from my batteries whatsoever. My batteries will stay at 100%. I'll be able to run my AC all day long, and if there's any amount of sun other than an overcast day, I'm producing excess power. So my batteries will stay 100% all day long, and then I'll be able to run my mini split throughout the night, which obviously is going to be run less or cooler because there's no sun cooking the tin RV that you're inside. So that's how it works, guys. If you have any questions, send me a message.